Hello everyone, my name is Robbie Siliberto, and my final project was based around performance increases in my ray tracer. The way this was achieved was through two methods. The first was by implementing multithreading to take advantage of multiple CPU cores during the render, and the second was by implementing octrees to divide object meshes. The overall ray tracing implementation was written in C# using the .NET Core 7 framework, and the program allows you to select a wavefront object file to be inserted into a scene. For example, we can use the bunny mesh and see what that looks like. As you can see, it takes about 18 seconds for the program to render the image. Now let's talk about the optimizations that allow this to run so quickly. The first optimization over the base renderer was multithreading. In C#, multithreading is achieved through a thread pool, which collects tasks to be completed and dynamically dispatches them to worker threads, which will take tasks from the queue and execute them as they become available. By default, the program uses as many cores or threads are available, but this can be limited if one so wishes. In my implementation, I created a task queue abstraction, which keeps track of the total number of tasks and the tasks that have yet to have been completed. This allows for the nice progress bar in the program while the image renders. In the render async method, we use this abstraction to create individual tasks that render a single pixel and allows the system to dispatch these tasks to available threads. The next optimization uses octrees to divide object meshes and reduce the number of ray triangle intersection checks. To do this, I created a special Octree bounding volume that recursively divides the mesh into smaller and smaller sections until each section has no fewer than 16 triangles inside of it. Thus, when a ray intersects this bounding volume, it can use simpler bounding volume intersection checks to traverse the octree and select fewer triangles to check for collisions. This took a lot of debugging to get right, as if the octree was not created correctly, it could result in silly holes, causing the mesh to look a little like Swiss cheese. Additionally, the number of triangles in each leaf node has to be tuned. If there are too few triangles in each leaf, for high triangle count meshes, we run into memory issues. But too many triangles per leaf will lessen the performance gains that can be achieved through this method. Overall, I think my implementation here could be improved, but it performs well, so I'm happy with the result. So let's take a look at the results. I developed my ray tracer on my MacBook Pro, which sports an Apple M2 Max chip and has 12 total cores, 8 of which are performance cores and 4 are efficiency cores. With no further optimization, this render takes almost 30 minutes. Adding multithreading alone reduces the time to around 3 minutes 8 seconds. And adding Octree subdivision alone reduces the time to around 2 minutes 16 seconds. Using both optimizations together reduces the total time from what was once almost 30 minutes down to a mere 18 seconds, about a 91 times increase in performance. So yeah, that's what my project's about. Thanks for listening. I hope it was interesting.